Good morning, ladies and gentlemen. Welcome to this talk about Project Velocity. So a quick question. How many of you know about Velocity already or used it? OK, good. Let's start with a small scenario example. You're a grocer. You have your small grocery website. People just come to your website to buy groceries, and life's going on great. Typically, the way you would have architected is you have an application tier. You may be running ASP.NET instances, which is accessing a backend database. And you have your clients coming in. You probably use sticky routing. You have in-memory ASP.NET session cards. Things are just fine, no problem, right? And then something happens. Gas prices start going up. Dow starts going down. Things we've seen recently. And then you have something that a lot of websites would love to have, customers, right? This is great, except if you're not prepared for it. Now, soon, people start complaining that, oh, website's running too slow. Oh, where did my shopping cart go? Your IIS web servers are probably rebooting under load, and you're like, OK, my shopping cart's disappearing on me, right? Well, what do? Your website's stuck. You cannot scale the website. You really have two options. First option, try to push as much stuff to the backend, maybe add more front-end tiers. Yeah, that's going to cost some money. You got to scale up your database, or if you partition, you got to do a lot of work, right? And that's your VC there saying, no, you're not going to do that option, right? The only other option is you can turn off customers and say, stop, we can't take any more customers. Are those really the two options left? Well, there is hope. I guess in the words of our president, yeah, there is hope is on the way. And that's what Project Velocity is all about. So through this talk, I'll show you and demonstrate to you how Velocity can help if you're a small grocery website or you're a large consumer website, how Velocity can help your website scale, perform, and make it resilient to all failures. All right, let's dive deep in. So this is going to be the outline of the talk. We'll first go through what it is, how it's going to help your website, and then we'll go through understanding the data usage and the programming, how Velocity actually works, maintenance, deployment, and what we're looking for going into the future. So what is Velocity? Velocity is nothing but a Windows service that you install on multiple boxes. They talk to each other, and they form this gigantic cache. So they give you this illusion of a gigantic cache. So if each box had, say, a gig of memory, you put 5 boxes, you effectively get 5 gigs of memory to cache. And that's what it is. It's an application cache, so you can pretty much throw anything application-related into it, CLR, .NET classes, anything that's serializable, and you can access it from any of your clients. So where does it fit in that architecture that we showed you before? It basically is going to slide in right in between your app tier and your data tier. Well, the data tier kind of disappeared, but assume it's somewhere there down there. So it fits in. So you put the clients within the app tier. The clients talk to Velocity, and your app can still talk to the data tier. So then the next question you're going to ask me is, so why do I use Velocity? What's the advantage it's going to get me, right? First, you can share data across applications. Whether it's your session data that you're going to put in, or your catalog, or other information, you can share it across multiple instances of your multiple ASP.NET instances. So you don't need sticky routing anymore, right? You can go to any of the boxes and access the same data. Second thing is performance. We have very good performance because it's all in-memory based. The only overhead is the network overhead itself. And we can do, on a quad-core box, we can do something like 30,000 operations a second. In fact, the 3 to 4 milliseconds latency is even lower. This is under load, under heavy load. If it's not even loaded, it's much, much lower than that. And writes, we can do something like 18,000 operations a second. Now you're like, maybe these numbers aren't good enough for you. Well, you can scale very easily. You can just add new servers and scale it pretty effectively. If you add 2 servers, we literally get very close to double the throughput you're going to get at the same latency. If you add 3, very close to 3 times the performance. So it's a linear scale as you go along. Finally, high availability. Even though you can if you put your session data in there, you're going to be worried about, oh, it's all in memory. What happens if one of the machines goes kaboom, right? We have high availability where we actually keep multiple copies around in the cluster. So even if machines die, you don't lose your data. Well, if none of this convinces you, here's another one. You can do it at very low cost. First of all we need is some memory and a network card, right, on the machine. You can really buy cheap machines, really cheap machines. And Velocity V1 is planned to be a free out-of-band release on MSDN. At least so you can give it a try. It's not going to cost you much. Well, then the next question you're going to ask is, OK, so what stage is it in? I mean, where is it right now, right? So we actually announced Velocity CDP1 at last TechEd. We went through CDP2 and PDC. We were supposed to release CDP3 today, but we wanted to take a 2 weeks time to actually change some of the APIs to make it compatible with .NET Framing Guidelines. So you would get CDP3 end of this month. And RTM, we're targeting a few months later in the middle of this year. That's the time frame we're looking at. And from then on, it'll be 6 months maybe for an SP1, and then a year after that for V2. So we're looking at kind of a yearly release cycle. Of course, there's another question that we often ask, say, OK, can I bet on it? Right? Can I take a bet on this thing? Absolutely. MSDN Forums today is already live on CDP2. They've been running for the last 3 months on our bits. So anything, if you go to the Microsoft Forums website, everything that you see there is running on Velocity. We have actually a number of customers all across the sectors, from media. In fact, one of the big media guys, they're just waiting for us to give the permission to go live. Content providers across the spectrum. So it's not restricted to one industry or one specific usage. It's across the industry. All right, so if you're convinced that Velocity is something that you want to give it a try, let's dive deep in and see how it works and how you can use it. Right? Before we jump in and use Velocity, the first thing you got to understand is the data usage. You got to figure out, given your application or given your website, what are the kinds of data that you want to cache? And we kind of taxonomize the data to be cached into 3 things: reference, activity, or resource. And the reason we characterize them into those 3 parts is so that each one has different characteristics, and you can easily pick and choose, OK, if it's reference data, I know I can use this cache feature. Or if it's resource, I know which cache feature to use. So it makes it easier for you. So to illustrate what these kind of data would be, let's take the reference data. So what reference data is something that doesn't change very often. So if you take your catalog, for example, that is reference data. You probably refresh your catalog a day per day, or maybe once in few days. Right? It doesn't change very often. So it's extremely cacheable. If you look at forums, for example, pretty much all of the forum threads, if you add a thread to the forum, that's it. There's no update to it ever, right? It's pretty much read-only from then on. So they have actually 5 Velocity servers, about 40 gigs of data across all of them, and they get about 98% cache hit ratio. They don't go to their backend at all. So their SQL Server load came down from 60% to like 2% now. So that's the order of, that's kind of the performance and scale that you can get by throwing in these servers there. And you can imagine if you go to Facebook, MySpace, all of them use these distributed kind of cache servers. They don't use Velocity, but they have other cache servers that they use. But basically because reference data is easily cacheable. In addition to having these cache servers, you can also you can also have local caches in your web tier that can also help. The next kind of data is activity-oriented data. And as the name suggests, this is data that comes out of a user activity. So if you take a session cart, for example, as you go shopping around, adding carts, objects to your session, that's activity data. And the activity data obviously is not shared amongst users. So your shopping cart, you're the one who's going to read and write. So it's read and write, but highly partitionable. So the scale requirement is that we be able to handle a large number of shopping carts. So we took a look at one of the online insurance folks who are working with us. If you look at their architecture, the way they're going to do it is they have these vendor services and catalogs, which is reference data, right? They aggregate it across from different people. That's reference data. That doesn't change very often. When you go to their online website and actually purchase the insurance, going through the process of doing all that stuff, that's activity data. And they want to store that in the cache for performance reasons. And finally, usually this data, once you're done with the activity, when you check out, it gets retired to either backend data sources or gets thrown into some workflow for further processing. And another important feature that you need to understand is if you store activity data in the cache, you do need high availability. You don't want to lose your user's shopping cart. Third, final kind of data is resource data. So this is data that's both read and written by a large number of people. So if you look at your seat inventory in airline reservations, that particular seat map that you see and you click and choose your seat, that's resource data. Right? And here, you got to be able to scale for both reads and writes at the same time. And businesses do try to kind of cheat a little bit, where, for example, in airlines, they do overbooking so that you can kind of scale through the technology, whatever we have, but have some business mechanisms to apologize later if, for whatever reason, the consistency can be lowered to have higher scale. So if you take a look at our grocery website, even here we can clearly see all these three different things. You have the catalog, which is reference data. You have the shopping cart, that's activity data. And if you had an inventory of how many items are left in our grocery, in our grocery, that's your resource data. So to summarize, you got to understand your data requirements. You have to first classify your data, whether it's resource, reference, or activity. And then you examine the requirements of the data. This is important when we go, as we go through the talk, we'll understand why each one of them makes a difference. Obviously, you've got to understand the performance. What's the latency and throughput? That's needed because you need to figure out how many machines you need to get, right? Consistency, how much tailness can be tolerated? Can I have multiple levels of caching, right? So consistency dictates those features. Eviction, is the data evictable? Can the data be kind of out of the cache, or do you need all the data to be in the cache, right? Security, are you bringing very secure data? Maybe catalog, you don't care. Maybe it's some other secure data. There's security involved, so you need to see, okay, what are the security that I've got to put around the cache? Finally, availability. Do you need this data to survive node failures, or if the entire cluster goes down, do you need that to survive? So once you understand this data requirement, then you can dive deep and see, okay, which features of Velocity make sense and how you go about using it. All right. So now that we took a look at all the data requirements and everything, let's go and see how Velocity, what are the usage patterns of Velocity, how it works. We'll go through a number of demos in like how to integrate Velocity into the grocery website, how it scales, and how we can make it available, and also a demo on notifications. First step is deployment. So typically, how do you deploy Velocity? As I said, you basically install the Windows Cache Services on one or more boxes. And we also ask you in V1 for a configuration store. So this configuration store could be a network share, or it could be SQL Server. So essentially some place where we can drop all the policy information and other information about the cache. Now once you've done that, you basically copy the Velocity client DLLs. There are like 2 of them that you have to copy into your app. You deploy your app, and you give us an app.config, and that's pretty much it. And the app.config, all we need is 2 things, really. One that says, what is the host name, a list of host names, so that the client can know to connect to at least one of them. You just need to give one of the server IP addresses. You can give multiple. In case that one is down, we can try the other one. But this is needed only when the client establishes the first connection to the server. Once it does that, it gets the map of all the servers, then it can talk to any of the servers. The other thing is local cache enabled false or true. I'll talk about that later, why that is significant. So that's pretty much it. That's all the deployment required for Velocity. So what is the API? For those of you who are familiar with CTP2, you should notice that there's a small change in the API. Instead of cache factory, it's data cache factory. So all the classes are now getting a prefix called data cache as part of the .NET guidelines. So pretty much you'll have all the APIs have now been one kind of block if you go to IntelliSense. So you first have to do a data cache factory. You do a new data cache factory. So that's going to read your app.config and grab all the server information. Then I'm doing a factory.getCache, and I'm giving it a name. That's called a name cache. So you can have multiple name caches, and you can access any one of them. And then all you do is do a put, where you give a key and a value. And the key is a string, and the value can be any CLR object or a byte array or anything that's serializable. And then you can do a get using the key from this client or any other client. That's as simple as it is. We also have another mechanism called regions. So if you want to put multiple objects together, so you can, like, say, delete them in one shot or enumerate on them and do other operations, you can explicitly create regions and throw objects into them. And when you do that, when you perform a get, you got to give the region again. So it's just a grouping construct. Remember, though, if you put items into a region, they will all live in one specific node. So there is scalability implications of that. You've got to be aware of it. You should create multiple regions. Don't put all the data in like one region. Then we won't be able to partition it and scale. So this is the logical hierarchy of velocity. So as we saw, you can have multiple number of machines. You can stripe multiple name caches on each one of them. I have a product catalog and an electronics inventory. And the reason you may want to do it is because, say, a product catalog could be reference data. You may have eviction off. You may have different policies. Inventory is resource data. You may have high availability on, for example. So you can have different policies for each name cache. And then within each name cache, you have all the regions, explicitly or implicitly created. And then we have the keys and the values. And optionally, we also allow you to tag items. So you can attach tags to items. And so this is the overall logical hierarchy of velocity. So you can connect to any of the name caches and give a key, get a value, or give a region, key, get the value back. Another way of accessing the objects is through tags. So you can attach tags. For example, I have toy region, toy 101. I wanted to attach hot items and discounted items to certain toys. Now I can actually look back and query based on, hey, get me all the hot items, for example. So it's a simple tag-based lookup. So it's a secondary way of accessing data. We also allow you enumeration. So if you go to regions, you can actually enumerate on all the values within a region. And it's an optimized, scalable enumeration. We do blocking. We kind of get it in bulk, so it's not like we go to the server every time to fetch every row. Another often asked question is, OK, now we kind of understood the basic API. How do you typically code to the cache? In V1, it is a cache aside, meaning the cache does not fetch anything for you from anywhere. You, as an application, you have to put stuff into the cache. You get things out of the cache, or you remove things from the cache. Right? So the way you would typically code is you try to fetch from the cache. If that object does not exist, then you go read from a backend, populate the cache, and return back the object. Right? So this is a cache aside pattern. Post V1, we're looking at a read through and write behind as well, where if the item is not in the cache will go and actually fetch it from the backend. But that's not there in V1. So we kind of saw the deployment and access API for velocity. So now I'm going to jump into a demo and show you how easy it is to actually take velocity, install it, and integrate it to our grocery website. Let me switch here. So this is my grocery website. I have all these things. I can just go click on these beverages. It's sleeping right now. So you see it gives you the detail about this item. It also lists you all the kind of related items. And you can add these items to cart. So you can basically just browse through it. It's a kind of a traditional website. I've also turned ASP.NET tracing on, so I can show you some interesting things as well there. So if you go back to my main website, you do see that it takes about 39.39 seconds, for example, to create this page. So the way this website is architected is basically that we have all the ASP.NET web pages there. We have a business layer, a data access layer, and a specific implementation of the data access layer using SQL Server. So right now, the cache is not integrated into this website. So if you look into the pages themselves, I mean, you guys should be familiar with this. Just a defaulted ASPX has, let me show you the design. It just has a bunch of data grids and data lists. And if you go to the implementation of those, you'd see that For example, the product category list, I'm getting it from the service layer. I'm calling the get categories on it or get popular products, right? And that's how pretty much all these ASP.NET pages are. And excuse me, if you go to the catalog service implementation, all it's doing is actually calling directly the data layer .get category, for example, or data layer .get popular products. So it's basically like a pass-through. It's directly calling the data layer objects. The data layer first, we have iCatalog provider interface. So these are all the APIs that are supported by this data layer. And specific implementation is a SQL Server implementation. So I'm using the Northwind database. So you see for getting all the categories, all we do is select star from northwind.categories. Or if it's a more complex query, like get me the top, I guess this is the popular products by category, you see it's doing all these joins to grab this data. Very simple website, very typical implementation, right? So let's see how we can kind of include the cache here. And as you can clearly see, one thing is there is a clear separation between the business layer and the data layer. So what I'm going to do is kind of slide in the cache layer here. So I will make the business layer now point to the cache layer instead of going to the data layer directly. That's all I'm going to do. So I'm just bringing in some existing projects that I have. So first, I'm adding a cache layer like the data layer. So all this is going to do is have an iCatalog cache interface that implements exactly the same methods as the data layer does. And a cache layer, all that is doing is basically getting the class name and just creating, out of reflection, just creating the actual class instance. That's all it's doing. And then the actual code for velocity, I'm just going to bring in an existing. If you go to the velocity catalog cache, again, it's a very simple implementation. The first thing that it's doing, so instead of using the app.config here, I'm actually explicitly creating the cache factory and creating a constructor with it and passing the server endpoint. So this is another way of doing it. So instead of putting all that stuff into your app.config, you can actually write code and just pass all those configuration to the factory right there. So I have this cache factory is taking 3 values. There's a server endpoint, and I believe the second one is whether you want eviction on or not, and the third one is whether you want local cache on or off. I'm going to keep it off for now. And if you look at the get categories, and pretty much all the APIs that iCatalog interface, again, it's kind of brain-dead implementation. All I do is I call the cache, I give it a key. Like, for example, category list, I have a key for it. If it's a product, I have like product, and then the product ID is the key. So that's the cache key. And all I do is look up from the cache. If it's not there in the cache, if it's there in the cache, I will just return the objects as it is. If it's not there in the cache, I will go to the data layer, grab the object, put it into the cache, and return that. So like I kind of explained before, that's how this velocity implementation is. And so I've just added these two. So now I need to repoint my catalog service. So all I'm going to do is do a quick replace of data layer with cache layer. I'm going to replace all. Done. I also have to add the reference to it. I've added those 2 references. We got to do 2 things. First of all, I didn't install Velocity yet, right? So let's go there and install Velocity first. It's an extremely simple install. We have both an MSI, kind of a GUI-based install, as well as a remote install in CDP3. So if you're going to install on multiple machines, you don't have to go through all this stuff. So I just clicked yes to the install. It literally takes about a minute. So if you have 5 machines, it'll take 5 minutes to install this on multiple machines. So while it's trying to install this, I'm going to go to the web.config and show you the changes I would have to do there as well. So I have to add this dcache client. Oops. which is saying that, OK, now include all the stuff from velocity. Then I'm also going to include these keys. That's going to tell our cache layer saying, hey, yep. One second. Let's finish this and come back to the install. So I'm just saying the velocity host name is my laptop, the port, and the cache host name. I don't need this catalog cache here. And that's the stuff. And we also had this extra. So this is needed if I use the cache factory without any of the arguments. Since I use the cache factory and I'm passing all the values there, this particular segment is not exactly required. You have a question? Yes?
I'm not clear on why why can't you just have a separate cache layer that implements the same interface as the data layer so you don't have to change interfaces?
I didn't. Oh, sure, you could do that too. I mean, in this specific example, I had my business layer. The service layer was directly calling the data layer, right? So I just had to flip it to say call the cache layer. Yeah. If you already had a cache layer, you could just sort of implement velocity. Or like you said, under the data layer interface, I could have implemented velocity. Yeah, both work. OK, so we've done that. So let me start a build here. And while that is building, let's go back, finish the install. Install's hanging here. So you see the install, all it's asking you is for two things, either a network share or SQL Server. I'm going to use network share. And I've already created a network share here. So it's Murkris2. I believe v1 demo, shared config. I test the connection. Yes. I give it some cluster name. And I choose the cluster size. The cluster size, all it determines is some internal things like, OK, how many partitions to create and all that stuff. It just automatically fills in those values for you if you specify the appropriate size of your cluster. And you also have to give the service port, cluster port number. We open 3 ports on every machine. And finally, the max cache you want to cache. So in this case, I'm saying cache about a gig, right? Don't exceed a gig. So that's kind of the max cache limit. I just do a save and close, and Velocity is going to go ahead and install itself. I hope my rebuild succeeded. Oh, yes, I forgot to add my catalog service. I forgot to use this guy. What did I miss? OK, Velocity is done. Install. Oh, yeah. In my Velocity, I also have to add a reference to the cache layer. All right, it's done. Let's go back, refresh this page. Oh, one thing I did forget, which is I didn't create the name caches. So it's going to fail now. So here, Velocity succeeded in install. It has created this admin tool. In Vista, I have to run as administrator. In Windows 2K3 and all that, you don't need that. That's going to time out. So let me start the controller. So we have PowerShell-based way of administering the cluster. So you can actually control the entire cluster from any one box. First, I have to start the cluster. So I do the start cache cluster. And then I need to create the appropriate name caches. In my example, I need the top 2. I'll tell you why. So I use the catalog and reports. The catalog is actually going to have all the catalog. The reports are those popular category. You know, on the right side of the page where you saw all those popular products, that's put into reports. And the reason you may want different name caches in this scenario is because I have a different expiration policy. So as you can see, I'm saying eviction none for the catalog and eviction LRU with a TTL of 1440 seconds for reports. So the 2 caches are created. And let's go see if it works. I believe. This is what happens in a demo. So my service is up. And make sure I have my web.config right. No, this is still an old build. I mean, the data cache is changing today, so I don't have the latest build. So. Where did I catalog provider? Yes, I have my cache layer. Let's make sure it's here. Yep, this is fine. It's not able to contact the cache. Let's make sure it got everything here. Yep, it should work. If it doesn't work, I have pre-recorded this yesterday, so I'll show that to you. It worked on this laptop, trust me. So. Typically, sometimes, if you just close the browser and restart it, it's fine, or I'll just restart the IIS process. Yeah, there it is. Interestingly enough, you see some red and blues. What I did was I said if things come out of the cache, I just set the color to blue, just to show you in the demo that. So if I refresh the page, you should see that it all turns blue. So you know it's all coming out of the cache. And one interesting thing to show you is we have so these get cache statistics and also catalog. So you see about 164 and 30 right now, so I do a refresh of the page. It does about 100 lookups on the cache to create this page. So it's for you see every single product you see here actually goes to the cache, grabs it. Every single line here is doing that. And if you see that, if you actually see the page, you should see it's about taking about 7 milliseconds or so, right, to do these things. 7 or 70? Yeah, I guess 70. This is where the local cache becomes interesting. Now, in the catalog case, so imagine for every request, I'm actually going across TCP/IP to grab this data. But 70 milliseconds, remember, for 100 calls. So it's far lower than that, the actual per call cost. So I'm going to just turn on this to true. So that's saying turn on local caching. And if I run the same thing again, what did I do? Yeah. This time, again, let me close this and open a new window. Rebuild all started. Yep, succeeded. And I'm going to do a refresh. And if I go down, you should see it's come down to 6 milliseconds, right, for the whole page to grab everything. So you see the order of magnitude difference, right, just turning on that small thing called a local cache. I'll show you in the slides subsequently how the whole thing works, how the mechanism works, so you can understand it better. So you saw how simple it was to install Velocity, just add this stuff into the existing grocery website. Now I have a cache for my grocery website, right? Any questions? All right, let's continue back with our slides. OK, so we saw how the demo, how we integrated this. Then the question is, I'll skip this slide. This is what we did. So how does Velocity actually scale? So we keep talking about, oh, yeah, it scales. So why does it scale, or how does it scale? It scales because it is a partitioned cache. So what it does is, as you add objects, it distributes the objects across the whole cluster, which is why, as you add more machines, we have more things to distribute against, and we can have better scaling, right? And the way we actually do it is this way. You give us a key. We map it to one or more default regions. And you give us a region and a key. We again map it to region. And then we just hash on the region name. And that number that we get, we basically bucketize it into a set of buckets, basically. If it's 0 to max int, we just take like 10 or 20. Remember that I said if you choose small, medium, or large, we automatically create the number of buckets. That's the number of buckets we create. So if you have a small cluster, we'll create a small number of those things. If it's a large, like a 100-node cluster, we'll create maybe 1,000 partitions. So those buckets are called partitions, these things. And it's the partitions that get mapped to a node. So which is why it's a coarse-grained mapping, right? So it's not like we take every key and say, oh, which node it goes to, because then our map will be as big as the cache. So all we do is we take a key, we map it into a bucket, and then the buckets get mapped to a node. And this information is also kept in all the clients, in all the Velocity clients. So when your app is actually trying to say, put me this key, the client first does that mapping thing that I just explained before, figures out which partition this key goes to. It contacts that routing table to figure out which machine that partition should live on, and it then directly talks to that machine. And the machine does the put operation and then returns the value back to the client. So this is how a put works. So that's why the clients can directly talk to any of the machines based on the keys you give it. Similarly, if I'm doing a get operation on a different client, the routing table knows which machine to go to. It directly contacts that machine and returns the value back. So that's how the partition cache works in a nutshell. Of course, the first question you're going to ask me is, what happens if the routing table is out of sync? Not to worry. The routing table is kind of asynchronously maintained. If it hits a machine, the machine doesn't have that data for whatever reason, maybe load balancing or whatever has moved the data out, it'll give the new routing table back to the client. So routing tables are kind of asynchronously maintained. So partitioning increases both your scale and performance. And the reason, as I said before, as you add more machines, you have more memory to cache, and hence you can scale on it. You can also scale on the cache throughput, because as you add more machines, you have more, you can distribute the load across all the machines. So I'm going to show you a quick demo here, which proves this point. And for this demo, I've actually recorded it because it needs about 20 machines. And the machines all got taken away yesterday, so I had to record them quickly before they took it away. So what I have is I'm using the Visual Studio Load Test Controller. So that's in VSTS, which can actually spawn tests for you and actually run it on multiple clients. So I have here this particular class. Unfortunately, it looks a little small for some reason. What this class is doing is really put, get, and remove operations. So this code it's like kind of simulating a shopping cart. So it's creating a new shopping cart, doing a put to the cache, grabbing the data, it's doing a get from the cache, and then calling a remove. So it's 3 cache operations it does. And this is going to be executed in about 60 threads across 10 clients from 10 different machines. So they're going to attack one server, and then I'll show you what happens as you add multiple servers. So these 3 are the servers that you have, 14, 15, 16. The web.config is just, I was just showing you it connects to one of the servers. So 14 is one of the servers. There's no activity right now because the test hasn't started. 15 is another server. This is the server I'm going to keep on. And 16 is the third server. So let me go back to 15 and show you, if I do a get cache host, you should see the status of all the machines. So you see that 15 is up, 16 and 14 are down. So only one server is up. So let's go back to our test and see what happens. So the test is just about to start. Yeah, so the test just started. You see these red, green, and blue lines. The red line is basically the user load. So that's going to go up to 60 threads. The blue line is the response time or latency. Right now it's showing 7 milliseconds for 3 operations together. The green is the throughput. It's showing about 2,800 iterations per second. So you multiply that by 3 because each iteration was those 3 cache operations. So roughly about 7,000 cache operations per second. You see something's happening, right? It kept going up, and right now it started to flatten out. And actually, the throughput is going down. The response time has gone up. It was as low as 7. It's 16 milliseconds now for the 3 operations. So why? So we'll quickly see why that is happening. If you go to machine 15, you should see that the network card on that machine got saturated. Not the network itself, the card on the machine got saturated because of the number of requests. You see it hovers close to like 90%. So let's now add a new machine and see what happens immediately to the system. So I'm doing a start cache host. I've already installed Velocity on the other 2 machines. I'm just doing a start cache host. So the moment this host is started, it'll talk to this existing machine, kind of form this new cluster, and then there is a mechanism where we now say, oh, now here's a new server, and that server is free. Let me move half the load to this server. So it'll actually move the data over to the other server, so the load is now balanced between the 2. I can do this command called get cache region that's going to show you the region distribution. When I do that, you'll see that within like 2 seconds or so, 14 has already started to get a large number of the regions. All this data got moved to 14 quickly. And if you go to 14, you see already the spike, right? It's already up to 60% load. Now, if you go back to our thing, you should see immediately the spike. So now we're up to 4,000 iterations, like 12,000 cache operations per second. And the response time also went down to like 4 milliseconds per operation, right? So response time also halved. So throughput doubled, response time halved, because we added a new node. So let's go add another third node and see what happens to this thing. So I'm doing a start cache host, and I'm going to add 16 to this mix. Again, immediately what will happen is now it will look at 16 and say, OK, now let's redistribute the load so each machine gets about a third of the load. And this is all true. You can actually try it for yourself. There's no magic here. The only thing you may need is a large number of clients to saturate the boxes. All right. So let's do a get cache region. And you see that 16 has already started to get part of the data, right? And if you see 16, it's already up to 40%, 40, 50, 60% now. And if you go to 15, it's taken part of the load now. The load would have gone down a bit. See, it gone down a bit. And if you go to 14, it's roughly hovering around the same. And if you finally go to the machine, you see that the throughput further went up to 15,000 operations now. And the response time went down to like 3 milliseconds per operation, per cache operation. It didn't quite double here because this load is not enough to saturate all 3 servers. So if I increase the load, the throughput would also go up. So that will be 3 times the throughput. So this demo kind of showed you how velocity can truly scale as you add new machines. Any questions? All right. Yes. The question was, is the cluster size dynamic? Yes. The only thing I would tell you, though, don't go from a smart to like a really large cluster in one shot, because at install time, we do choose some defaults. So it's good to kind of stay in that boundary. You can change all those defaults, by the way. So we saw how if you go to the cache services, now the scale works very well. And one thing I told you before in that previous demo that, hey, if you turn on this local caching, it can help you a lot. So what is local caching? So local caching is nothing but enabling kind of a local cache in the client. So nothing much changes on the put itself. But if you do a get operation, what we do is, if you have local cache turned on in your client, we keep a copy in the object form in your app, in our client library. So when you do subsequent gets, it can short circuit and return back immediately. So that's what it does. So local cache, for example, can do something like 200,000 operations a second. And local caches are really great if you have reference data and data that can tolerate some staleness. So because the local cache could be out of sync with the cache server for some duration of time. The next question you're going to ask me is, OK, how is this kept in sync? Right? You have 2 mechanisms. One is an expiration-based mechanism. So anything that comes into the local cache, you can say keep it only for 10 seconds or 1 hour or 2 days, depending on the consistency and the staleness of the data, the staleness that you can tolerate. And the second thing that we have is a new feature that we have added in CDP3 called notifications. You can actually subscribe to notifications, and the cache will send out notifications to these clients to say, hey, this key changed or this value changed. And it's a poll-based notification, so you can actually also say how frequently we want that polling to happen, that notification polls to happen. Now we saw performance. So with local cache, you can get performance. You get scale with partition cache. You get performance with local cache. Now we're going to see how we're going to get high availability with the cache. So let's take the same operation, the put operation. Like I said before, all you have to do is turn on HA in the cache, in the name cache. And what it does is the cache automatically figures out a backup node for each partition. It happens at a partition level. And it makes the copy and then returns back to the user. And the gets, the same, nothing much happens. It always goes to the primary node, if you will. So this cache 2 is called the primary for that partition, and cache 1 is the secondary or backup for that partition. In V1, we'll allow you to keep 1 backup copy. Post V1, we're going to allow you to keep multiple copies around. If your machines are really flaky, you want like more than 1 copy. Now let's see what happens if cache 2 goes down. So when cache 2 goes down, we have this layer called a cluster or a fabric layer, where the neighbors kind of keep watch on each other, saying, are you alive, kind of thing. And when cache 2 dies, cache 3 immediately detects the fact that cache 2 died, because we have a lease interval, and it fails. Then it contacts another cache, which is running this thread called a partition manager. And any machine can run this thread. All this is doing, this partition manager will distribute the data, or that's the one that says which partition goes to which node. It's like a global manager, if you will. And that partition manager detects that cache 2 failed. Cache 2 was the primary for this partition, like K2, V2. So then it tells cache 1, which has a backup copy, to make itself the primary. This happens within like a second or two. And then cache 1 will initiate a new backup copy to be created on another machine. So this is how, in a nutshell, how the whole availability works. And the first question I often get asked is, OK, what happens if cache 4 fails? Not to worry, some other machine will pick up and start running the partition manager. So it's fully resilient, fully available. So if you store your session data in there, nothing's going to happen to it unless you bring down the whole cluster. And before I jump to the demo, I want to quickly show you what we do with session card so the demo makes more sense. All you have to do, if you use ASP.NET Session, so ASP.NET, for those of you who are not familiar, ASP.NET has a session class where you can actually add items to that session that's tied to that user session. ASP.NET provides a provider model, so anybody can plug in and be a provider to host that session. Velocity also implemented that. You just need to add these 5 or 6 or how many other lines there to the app.config or web.config, and immediately all the sessions come into Velocity. And the moment it comes there, you can scale your session store, you can make it highly available, and you don't need load balancing anymore. So I'm quickly jumping to a demo and show you how this works with our grocery cart example. Let's jump here, back to my machine. Actually, I have remotely logged into my machines at work. I have 2 machines here, Anil Nori 4 and Tweedy. I've installed the same grocery example on both of them. The only difference is I've also integrated the shopping cart with Velocity. We didn't see the shopping cart quite yet. If you look at the product.aspx, you see this Add to Cart button in there when it comes up. Yeah, there you go. So there's this Add to Cart button, right? And this is implemented in this ASP.CS. And if you look at the Add to Cart button, what it's doing is it's going to the ASP.NET session and looking for that shopping cart. If that shopping cart doesn't exist, it creates a new shopping cart. Otherwise, it basically just adds the item that you have that you just said Add to Cart into that shopping cart. That's all it's doing. And if you go to the web.config itself, I have added that 5 or 10 lines required. That says, please use Velocity as the session store and use this name cache called session to actually store the values in there. And I have created this name cache called session. Oops, I should have gone to Anil Nori 4. So I've created this name cache called session, which is basically highly available. Let's see, is that session? Yeah. Right now, there are no items in any of them. So I have catalog, reports, and session. So as you see, there is no items in any of them because we haven't done anything yet. OK, so now let me try to go and actually access the items in the cache. So I've said Anil Nori 4, said not win cache demo. It's a usual cache demo, so I do a refresh. Everything turns blue, right? Favorite thing, same thing again. Now, I've also installed, like I said, I also installed the same application on Tweedy. So I go here. I go to Tweedy. Remember, this is the first time I'm actually accessing Tweedy. One thing you should immediately see, it's all blue, right? It wasn't red. The simple reason being, because Tweedy is also accessing the same cache, all that reference data was already in that cache. We didn't have to go to the backend at all. So that's one clear illustration, right? If you also use the cache for reference data, you don't have to have every machine going, hitting the backend and populating that stuff. If you use local caches, that's what you have to do. Whereas you don't need that anymore with Velocity. Now, let's, one thing before I jump, let me go back here. If you do a get cache region, you should immediately see that the cache regions are being distributed across all of them. This is reports, this is catalog, and this is session. One difference you should see between session and catalog and reports was because I had HA on, you see primary and secondary, right? So I see Anil 4 is primary and secondary for 2 of the regions. Tweety is the secondary and primary for the 2 regions. Whereas for catalog and reports, I did not have HA on, so you only saw primary. There was no secondary. All right, so let's go and add some items to my shopping cart. So I'm just going to choose some stuff. By the way, I have no idea what half these things are. This Northwind things has some funny items in them. Maybe the scones, I don't know. So let's add to the cart. OK, so we have these 2 items in the cart, right? Yes, you have a question. I'll come to that. Let's finish this demo here. So these are the items in the cart, right? So let's go to Anil Nori 4 machine, and I'm going to view the cart. I'm going to click on View Cart. There are no items in this cart because I'm going to a different machine, so the session is different between Anil Nori 4 and between Tweety. So obviously, you should not see someone else's shopping cart, right? So let me do some spoofing here. I'm going to copy this stuff here. So this is equivalent to the load balancer taking you from this machine to the other machine, right? Passing this session ID here. Now you saw immediately, you should see the cart there, right? So I just spoofed the session from Tweety to Anil Nori 4. You can also see the cart on Anil Nori 4. All that means is you don't need sticky routing anymore. If the user hits it with a session, you can go to any of the machines because the session data for that user is available to all the ASP.NET machines, right? So you can really scale your website. You don't need sticky routing anymore. Now that we have done this, let's do some killing, right? So let's first kill Tweety. So let's assume the IIS server that's hosting the application keels over. So I'm doing a stop on this. Remember that nothing should happen because the data is not in those ASP.NET machines really, right? They're sitting in the Velocity instance itself. So just because I killed it, so I killed this machine. So let's go close this here. Now if I go to my Northwind cache demo here, it should come back with, yep, the website is, the ASP.NET machine is down. But if I go to my Anil Nori 4 here, this resolution is really painful. You see the cart is pretty much there. Pretty much all the items are there. Nothing has changed because all the items used to live in the cache, and the cache is pretty much up and running, right? Now let's do something interesting. Let me go here, and I'm going to start killing machines. In this case, Tweety hosted 2 of that session's stuff. So I'm just going to stop Tweety. So the stop is equivalent to a kill. We just send an sc.kill. Pretty much, we just kill that service directly. So Tweety is down. So I do a get cache region now. You should see that within about a second or 2, you see Eagle is starting to get, you saw that? Within about 2 seconds, you saw Eagle now actually having those secondary. Anil Nori 4 had 1 primary and secondary. That secondary on Anil Nori 4 got promoted to a primary, and then Anil Nori 4 created a backup on Eagle for that session. Remember, for the other ones, the catalog and reports, we did not have HA on. So when I brought down Tweety, it would have brought down some of the partitions, right? That data in it would have gone away. But it's OK, because as the website actually accesses these items, they'll get populated from the backend seamlessly. So let's see what happens. Now I kill this machine. I'm going to refresh this page. Oops. Because there are some regions where it's still moving around. So in about a second or 2, you should see that, yep, there you go, the page is coming up. Let's make sure. Yep, Eagle and Anil Nori 4 are fine. Let me go back to the front. Oh, there you go. Just took a little longer. And you see some items are red, some are blue. This is what I said, right? For the catalog and reports, because I brought down Tweety, some items got displaced, but it's okay. As people access the website, they get populated in. And let's go back to our cart to make sure it's still around. Actually, did I change the session ID? Ooh, I lost that session ID. Wait. I think this was a session that I had. Yeah, see? Shopping cart is still around. Nothing happened, right? You didn't lose your shopping cart. Now, let me go back to this machine. If I can also further kill Eagle. Should I do that? It's down, and if you see this, you see that now everything gets moved over just to Null Node 4. The secondaries and primaries just get created in Null Node 4. In this scenario as well, the catalog and reports would continue to work. There'll be no problem at all. The only thing that I've done, however, is I've said for the HA, for the session cart alone, I've said do not take writes unless you have at least one backup copy. And because of that, I cannot really do anything to the shopping cart. But in the future, you should be able to actually say, actually take writes even if you don't have a backup copy, even if you don't have enough machines to create backup copies. You actually will have that option as well. So if I now start cache host, say Tweety, you should see that it picks up again, it distributes the load, and I can start my website will be all fine again. So this illustrates that Velocity can help both scale your session, it can make it available, and you don't have a problem. And even for your reference data, you see how you can really scale up as you add multiple instances. You have a question? Yes?
Is there a way we can take advantage of Velocity to rewrite other data caching similar to what you did with the session state?
Right. Good question. The question was, can we reuse Velocity to take advantage of what we have already done? Do you use system web caching, for example, today? Or yes. Unfortunately, the problem is system web caching is not an extensible class. In Dev 10, in .NET 4.0, they're adding a new thing called system.caching, which has a provider model as well. And Velocity would be one of the providers in that scenario. As of now, if you are using system web caching, unfortunately, you are directly referencing that class. So we can't say, OK, now Velocity is an instance of that. However, if you've laid it right, if you have like this interface implementation, then you can easily switch to using Velocity. Right, so I added Tweety. Everything is back to normal. You should start seeing that my cart works and pretty much all the apps run. Right. So that's my demo. Let's go back to our slides here. And how much time we have? 2 minutes left. We have a few more features. One is locking. We do both optimistic and pessimistic locking. Optimistic means that you don't want to take actually a hard lock on the object. So what you can do is we have actually versions with each item. So as you add items, we atomically increment the version number. So you can grab that version and send it along with your update. So whoever comes in first, in this example, thread 2 came in first. So that put will succeed, whereas thread 1, which actually got the same item at the same time and updated it, because it came a little later, it won't succeed. So it's a classic optimistic version-based concurrency control. And you can read more about it online, and also some of the blogs that we have. Pessimistic locking, you just do a get and a lock. It's an explicit lock, so anyone else trying to do a lock will fail. And we ask for a timeout on a lock so that if the client dies, the lock is not left hanging. So locks have timeouts. Regular gets will continue to actually work. It will keep serving the old data, the pre-locked data. And put and unlock are mechanisms you can use to unlock this object itself. Another big thing that we have added is notifications. So we've added actually a scalable notifications feature in CDP 3. I will quickly show you that demo of that as well. And basically what it does is you can actually register for either a key level, a region level, or an entire cache level notification. So if anything changes to that object, you can get notified. Right? Let me quickly show the demo, and then that's the last demo for the day. So I've actually created another thing called Northwind Cache Demo 2 application. And let me just restart my. And the only difference in this Northwind Cache Demo 2 that I have is as users browse through the catalog, right? I have, when you click on that product and say, hey, show me the product, I actually insert something saying, oh, this user viewed this product, right? And then I actually listen for the notification. So right about here, I've actually added a register event call here that says anything happens at the entire cache level, call this browse delegate function. And I've also created this new cache called browse log. So it's like an archive. Think about it. As users click on the thing, I just throw this saying, oh, I access this product into the log. Somebody listens for it saying who are all kind of looking at this log. And then I just present it in a page. So that's as simple as it gets. You can get fancy. You can imagine notifications are useful in a variety of situations. So this is all it does. Let me close this. Website is up. This is localhost, Northwind cache demo 2. Oh, I forgot to create the other cache. Oh, browse log already created. OK, cool. All right, so Northwind is here. So I have this page called browse log. All that does is, remember that browse delegate that I had? All that browse delegate did was add these things to a list, saying, OK, people access these items, this many count kind of thing. And I just display the list in the browse log. So right now, there is nothing. And this page is auto-refresh, so it refreshes every second. Let me go click on this item. Oops. You should immediately see that this came up here. I go click on dairy products. I do some detail. You should see that comes up here. So I've set the notification polling interval to like 1 second. So every second, it quickly polls the backend server. So you see that, right? Very, very simple demo. So you can see the importance of notifications. Xbox is actually going to use this notification feature for their entire presence information, for example. And they require like millions of operations per second across like 40, 50 boxes. So it scales up to that level. And the way it works is very simple. There is nothing kept on the server. If you register for a key, we figure out which partition it maps to. We poll that particular servers and ask them to send the log. The servers only keep log of all the changes that have happened. They don't know which clients are talking to them. It's like an RSS feed, right? A classic RSS feed mechanism. And then the clients grab that information. The next time they poll, they'll say, OK, send me all the changes since 21 or 30. This is the last log that I saw. Send me everything after that. That's how it works internally. All right, I'm going to kind of jump over a few of these things. We don't have too much time. Security, we're going to allow you a domain-based security option, so you can actually turn on security if you like. Obviously, it comes with a penalty. Then administration monitoring, we have installs and remote MSIs and administration through PowerShell. Sizing your server is very simple. You got to assume linear scale for throughput. So once you know the throughput for a single box for your application, you can just multiply that by the number of servers. So let me jump into some of the features that we're doing. Assume you became very popular. Your grocery became a very popular website. And suddenly, you get a lot of scale, right? What do? One of the things you're going to do is go to Azure, right? If you want to go to Azure, Velocity will be there for you. So you could choose to just store your data in Azure, right? In which case, you can still have your application on premises. You can use Velocity as a cache there, and just put your data back in Azure. And this is where Velocity will be very useful, because the access times to go to over the web is going to be very high. If instead you choose to basically put the data in Azure and your app in Azure, that's OK too. We are working with the Azure team to actually be able to have Velocity role instances also running in Azure. So even if you access local data stores there, you can actually deploy the app along with Velocity in Azure. So both of that we're working on to make it work in Azure. Another big thing that we're doing, this is to answer your question, is with ASP.NET 4.0, we're getting a number of hooks into ASP.NET. One thing is the cache surface is increasing. In a sense, they are going to open up the application cache by adding this new system.caching namespace. We will be a provider for that. They're also making the granular session updates. Basically, remember today with ASP.NET Session, any change you do, even if it's a small change, they give us a whole glomp and then ask us to store and retrieve, which is, if you have large sessions, it's going to be a lot of overhead. They're opening that up. Finally, output caching as well. So you can use Velocity as a web cache now. So ASP.NET is going to open up the output caching, again, make it a provider model. So you can plug in Velocity there. So if you have pages created, it can also get stored in Velocity and serviced out of Velocity as well. Another big thing is cache through. Like I said, V1, it's cache aside architecture. Post V1, probably in SP1 release, we will have a cache through where as you can actually, we'll have a callback on the server side. So if the item is not there in the cache, it'll go to the backend, fetch it. Or if you write to the cache, it will write behind asynchronously to the backend. Another big thing we are doing for V2 is link queries. So you will be able to actually do proper link queries on the cache. And we will talk about, going forward, talk about more about what are the typing implications and all that stuff. But assume that we will do sort of a federated query. We'll be smart enough to only go to the limited set of servers and return you back the object. So you can do something like from catalog of toy, where toy price is greater than 300, return me all the toys. So you can subset all your reference data and such. Another big thing is grid computing. So we did some benchmarks where if you take a typical kind of a financial hedge fund kind of computation, if you throw Velocity in there, we got like 50 times improvement in some of the HPC workloads. It's just really orders of magnitude improvement in the HPC workloads. So we're working with the HPC team. HPC is Windows HPC Server, which is useful for kind of job scheduling, kind of map reduce like problems. And Velocity will be fitting in there. We're working with them for the next release to make it easy to install and deploy Velocity within the HPC. We're also looking to see, going forward, because Velocity has the data partition, maybe you can also schedule the jobs appropriately so you don't have to go across the network to grab some data. So we're working on some sort of embedded configuration as well. So that's pretty much the major kind of future work that we're working on. And sort of to conclude, the main takeaways from this talk, Velocity is an in-memory distributed cache for .NET. We saw how easy it was to integrate into a website. It's really simple to install, configure, and maintain. You can use it to help your app scale, perform, and make it highly available. And as you see, our roadmap covers both your local, on-premises, on-crowd, or grid compute as you go along, right? And the slogan I would like to use is Velocity will be there for you wherever you go, right, for all your data. And just to conclude, it will target all the web scenarios. We target all the enterprise scenarios by doing the link, co-location, and computation, and all the software plus scenarios, software plus S scenarios by integrating with Azure, and we'll have probably integration with ADO.NET data services. You have REST and SOAP access with Entity Framework and all the other cool things that we have. So that's it pretty much for my talk. So please, if you have questions, feel free to ask, and please fill out the evaluations and give it to Amber as you exit. Questions? Yes?
Doing the caching. I'm not a .NET developer, but
right.
In other frameworks I've used, when you give the developer the ability to control the caching, some things will be wrong. So generally, what happens is you have a person who does the database,
right.
Someone who looks at just the kind of caching infrastructure.
Correct.
That person does that and understands that really well. But if you give that power over to a developer, they may put in the cache when they really need to. And so what's happening is that you get in this kind of a person who's doing the kind
right.
of system caching, then you've got the kind of developer who's writing other kind of caches as well.
Right. So the question was basically, hey, if you give the power to the developer to do caching, would they misuse it? I guess to some extent, right? Like the two answers to that, really. One is you can indeed layer your business logic so that the caching layer is kind of not available to the developer. It's kind of done like the data layer, like the data access layer. If you implement it such that, then the cache owner, in some sense, can do all that stuff. The other option also is going forward, we're looking to see how, with like Entity Framework, for example, that we make it easy to make it cacheable. Maybe you should just have a flag that says make this cacheable, as opposed to the users explicitly doing the cache. So we're working on that as well. Yes?
Does the Velocity support any kind of cache dependencies or not?
Good question. So cache dependencies, this is an often asked question, not in V1, but in the SP1 and the post V1, we are looking at that seriously to support some cache dependencies. But we do expiration already today, though. Regular expiration is supported at an item level. It's just that dependencies are not tracked. Yes.
It seems like the cache nodes, they have to be on the same subnet, is that right?
The question is, do they have to use the same subnet? Not really. The difference, though, is there is a latency. If you're asking about geoclustering, is that the question? Yeah. Remember, when it's geoclusters, the latency between the clusters can be large. So to avoid false least timeouts, you would have to increase the entire kind of least time interval. So right now, it's like 1.5 minutes. You may have to make it longer, for example. That then comes with the added cost of failover detection, right? The time to detect a failure goes up higher. So that's the penalty you have to pay. We have not tested it with the cache servers across geo yet. We are looking at it, a formal support maybe post V1 as a formal geoclustering support. One interesting thing is with notification, I'm trying to play around to say, can I use like notification like a gateway to say, okay, have 2 cache clusters, use a notification mechanism to kind of propagate the changes over to the other side. That may be something worthwhile considering. Yes, question?
The notion of named regions, which guarantee like the
Co-location.
on the same node, I'm not understanding the need for the semantics of that on the developer side. Why would people use that?
Yeah, why would people use regions? If you take a look at, say, for example, sessions, like generally session, right? You may have a lot of properties for the user that you want to independently access and store, but you also want to treat it as a unit to deletion. Like, for example, you want to delete it in one shot. That's how MSN is looking at using it. So that's an example of regions. Regions typically work if you have small amount of data and where you still want individual access, like add, delete that data without having to fetch the whole thing, but treat it as a unit for deletion purposes.
I can understand that, treating it as a unit, but why do we have to know that it's physically co-located on the same node?
Oh, the simple reason being it'll be faster if when you're doing enumeration and all that stuff, right? It doesn't have to go across the network. And also in the future, when we do bulk operations, we're going to support bulk operations. When you give it in a region, we know we can send it in one shot. So it's giving you just that extra control. It's all about performance, right? So the more you know, you can kind of use the appropriate mechanisms to get the most out of the bang out of the box, right? Yes?
Notice the MSDN form people had you still had the load balancer in there. What was, if that was not a mistake, what was their load balancer type configuration and lessons learned? How did they change the load balancing afterwards?
Yeah, so the question is MSDN specifically, how they did the load balancer. Before, they still had a load balancer. They were not using sticky routing. They were still doing the regular load balancing. But all their caching was using system web caching, just in-memory caching. And it was not enough because the boxes didn't have 40 gigs of memory, right? Each box had 2 gigs. Whereas right now, they're able to cache 40 gigs because of the cache servers. So that's the big difference that they got. And also, all their session information itself, actually, they don't have session per se. The profile and other things were stored in SQL Server. They also moved that to using Velocity. So that's what they did. They didn't have sticky routing before. Yes?
I'm also wondering, like, with the notification mechanism and the notion of failover and stuff like that, how chatty are these nodes with each other, like in terms of network?
Good question. So the question is, how chatty are the nodes between each other? Actually, they're not very chatty. If you look at, if you don't have any access to the cache, the only communication that goes is a minute or so, we do this ping to do the lease interval. That's pretty much it. And when you do a put operation, if you have HA on, obviously there's that extra hop to do the copy to the other server, right? It's only when nodes go up and down that the server-to-server traffic goes up because we have to do some load balancing and all that stuff. But majority of them is also bulk, pushed in bulk, so it is not as chatty as you would think. The notification specifically what we do, again, that's a polling time interval that you can control. And within each poll interval, we are trying to send as much data as possible or in one shot. So it's not like every notification is coming like one at a time.
Is that also the case with puts? Like if you have a lot of like machine gun puts?
Good question. So do you have, in some sense, your question is bulk puts. We don't have bulk puts today. We will not have that in V1. We are looking to see to add bulk gets in V1 to improve performance. Right now, it's in the process of getting done. But bulk puts will come post V1.
So currently for every put?
It does, yes, that is correct. It goes to the server specifically. Any other questions? All right. Oh, yeah, sure.
One more. In your, I'm more of a Java person on the back end.
Sure.
So I don't know a lot about the .NET paradigm.
Sure.
I was looking at the code for, you were testing to see if there was a shopping cart in the session and if not creating one. Don't you need any kind of synchronization on that?
No, this is kind of created in memory. The ASP.NET session, the way it is created in memory. When the page exits, then it will store it back in the backend. But ASP.NET automatically, actually, at the provider level, takes locks and all that stuff. So we actually use a pessimistic locking for the session. So that is done by ASP.NET automatically. You don't have to do it as a programmer. So when you create a session, ASP.NET grabs that session ID. It actually sends a lock request for our provider internally, and then we take a lock on the key and all that stuff. All that is automatically done.
No, but in the example, you were testing the session to see if there was a shopping cart in there.
Yeah.
There was no shopping cart.
No. That is automatically loaded. What will happen is when the page is loaded up, based on the session ID, ASP.NET will first query the provider to grab a shopping cart and populate that session class in memory.
Oh, that was a page load time on.
Yeah, it's a page load time. Yeah. All right. So one more question. So go ahead.
Another question, just to say that was very impressive. That was great.
Oh, thanks. Thanks a lot. Yeah, and feel free to ping me mail. I'm murchris@microsoft.com if you have specific questions, concerns. And again, like I said, in a few months, we're going to be RTM, so you should be able to use it. And already a lot of customers are going live on CDP itself. It's fairly stable. And CDP 3 is coming out in a few weeks. It'll be pretty good build. So try it out, enjoy it, send us feedback. Right? Thanks.